histic soil, but it's enough, obviously, to turn everything black, and I don't have to put my nose to it to suggest that it's probably pretty reducing too. So that's going to be significant ultimately, and what happens is the selenium is transformed. This is how slide 17 shows how the distribution of selenium looks in the various core samples. Generally, it was low in the river itself, all the blue shaded samples here, except for this one peak right at site 7. And site 7 just happened to have a hole in it with a lot of organic matter and selenium bearing sediments in it. But this is all this blue is right in the Right Fork Reservoir. So we had one that bopped up to 1.2 milligrams per kilogram. Everything else was below about 0.2 milligrams per kilogram. And then once we got into the lake, then we started getting more consistently high readings up to 1.8. And these are at 5 centimeter depths. This is your shallowest depth, 0 to 5 in the blue. And then I'm showing one of the deeper ones, 5 to 10 centimeters. And there was not a whole lot of trend there. And I'll show you some more data on that. But it certainly dropped off once you got into the Left Fork Reservoir. And this next table shows you the distribution and depth of all of our cores from that we took in the reservoir. The average total organic carbon was about 2.2%, and the average selenium in milligrams per kilogram was about 0.66. So it tended to be lower in the stream than in the reservoir itself. We didn't see a whole lot of depth profile here. It seemed to be about 0.66 regardless of depth, although some samples got higher and some were a lot lower. The algal mat itself was about 1.3% organic carbon and about 1 milligram per kilogram selenium. Not as enriched as I thought it was going to be, but nevertheless, it's richer than what you're normally seeing in the sediments. And this is, shows you the relationship between total organic carbon, and in the red, you see the selenium in milligrams per kilogram. Not a profound or extremely robust correlation, but nevertheless, there is some trending upwards as you get more and more organic carbon. So, let's look at the biological impact. One of the things we did before we started out our sampling was sit down and talk with West Virginia DEP, Pat Campbell and Dave Montali and some of his crew. And they suggested to us that because they had been sampling larvae, fish eggs and so forth in the reservoir for some time, and we wanted to, as much as possible, use the same sampling stations and the same methods that they were using. And they suggested that what we do is dig up the entire red, R-E-D-D, which is like a nest, lined with shells and rocks, and take that up to our lab and then flush water through it as quickly as we could, and then try to hatch out the eggs and then look at any mutations. So they actually helped us. They were down there with our crew from Pat Mazik's Fish and Wildlife Service lab. Helped dig them up, took them back to the lab, and almost everything died because the ammonia went through the roof because there was so much algae in all the samples. Less so in Plum Orchard than in Mud River, and Pat just could not keep the ammonia concentrations down low enough to allow these to survive more than a couple of days. So we didn't get much joy out of this whole sampling routine. And we're going to redo that in a different way this summer coming up. Apparently, I just read the report that came out of West Virginia DEP, and they did not use the method they suggested we use. They actually picked up individual shells and then hatched the eggs out of the shells, and apparently did not have a problem with ammonia. So, anyways, we'll try it again. Nevertheless, we didn't pick up a whole lot of. We only had 16 actually hatched out of the Mud River, and didn't see any weird behavior there. Although 16 is not much of a sample.
Do you have any estimate of survival percentage? Just any idea what percentage actually?
From how many eggs we had originally?
Hatching success, yeah.
I don't know. No, we didn't collect that. And then we went in and did electroshocking and also netting to pick up the mature fish, and did the look at gonadal selenium, for example, and also total fish mass. And this is something that was surprising to us, but the concentration of in gonadal selenium was about 20 milligrams per kilogram. Here's our confidence interval, 95%. And this is POL is Plum Orchard Lake, which is our reference site. And even though the concentration was below 10 milligrams per kilogram, the variation was through the roof. And as a consequence, we really couldn't, we can't say that those are different, but they look a lot different. But we're going to resample that as well and just take a lot more samples out of Plum Orchard Lake next summer. If you look at whole fish, on the other hand, the difference is very significantly different. And the whole fish concentration is about the same as it was in the gonads, and that's about 20 milligrams per kilogram, relatively narrow confidence interval in Mud River. And then at Plum Orchard, it was real low, about 1 or 2 milligrams per kilogram in whole fish. Now, whole fish means you take a whole fish,